Okay, let's talk about something that confuses people. Let's take a look at this image that was placed on the Nikon D500. It's a 17 to 55 millimeter taken at 55 millimeters and f4.5. Okay, interesting, right? Now let's take a look at the same image taken on the Nikon D810 full frame sensor, 36 megapixels. Now, which of these is closer? Yeah, I think we're closer here than we are over here. No, we're not. We are 0% closer or farther away between these two images. What? That doesn't make any sense. Yes. Now, here's a secret that's not a secret. Every lens on Earth, it doesn't matter if it's made by Canon, Sony, Fuji, Nikon, it has no idea what size sensor is underneath it. It drops the exact same light with the exact same luminal density before anything ever touches the sensor. That lens is dropping the same light. So when we have a tripod that is unmoved, and the only thing we do is we switch camera bodies, we take the exact same 17 to 55 millimeter, exact same aperture, and we toss it from the Nikon D500 onto the Nikon D810, we are getting the exact same image projection. See, a crop is a crop is a crop, and is only ever a crop and nothing more than a crop, and never more than a crop and only ever a crop. That means that this image is the exact same as this image. Why? No, it's not. It's not the same. Yes, these two are the same image. See, the lens shot out the exact same light over the exact same exposure and aperture and time and the exact same distance between this and this. These are exactly the same image. Now someone's going to say, well, why didn't you move closer with the Nikon D810? Well, let's see. I'm taking a picture of a bird, and I'm standing on a pier. Now the bird is not going to move any closer, and I'm standing on the edge of the pier. So unless I want to jump over the edge of the pier into the ocean, I'm not going to get any closer. So these two are the exact same thing. Now, as far as the image noise, being the same, now we have the Nikon D810 on the right here and the Nikon D500 on the left here. Now, if it is the case, not if, it is the case that to print out an 8 by 10, to print out a 20 by 30, the exact same image needs to be blown up 2.25 times more on the DX crop sensor than we do on a full frame sensor. The factors that people don't take into consideration are three things: pixel pitch, gain, and signal processing. All exposure is gain. Okay, gain is two things: aperture and pixel pitch. Larger photosites have better gain. Also, signal processing. Now, the Nikon D500 has far better signal processing than the Nikon D810. There is not more noise here on the right, as predicted by someone. There is absolutely no more noise here on the right than there is on the left. Actually, I can argue that there is a wee hair more noise on the Nikon D500. Well, that's not possible. I was told that a DX crop sensor lens on a full frame camera will have more noise. No, it definitely does not. You see, what we're looking at here and what people don't seem to understand is that both of these are taken at the exact same distance, and the lens dropped the same exact light onto two totally different sensors with two totally different pixel pitches with two totally different forms of signal processing. So we have two different gains, we have two different signal processing, and we have two different pixel pitches. Now, it is the case, what you see over here on the left versus on the right, you see, that is not more noise. Like if we take a look at the NY versus the NY over here on the left on the Nikon D500, that is resolution. You see, the exact same light that was shot out of that lens onto the Nikon D810, there were less photo sites there to gather information. On the left here, we have a 47 megapixel sensor. What? Yes. You take the megapixel of the Nikon D500, 20.8 times 2.25, you have what would be the equivalent of a 47 megapixel sensor. That means if you take little tiny details like this, there is more information gathered, assuming, of course, we don't have, really bad high ISO, really low light. We have a good, decent exposure. We have more information gathered. See, this is the reason why bird shooters using $20,000 lenses are using them on $500 cheapy cameras. Okay? There's not more noise sticking that DX. See, these are both exactly the same lens, same exposure. Now you see what you see over here on the right, we have slightly different color saturation. That is a product of the sensor and the signal processing. It's different on the D500 here on the left than it is on the right. Obviously so, right? We are not seeing more noise here on the right. Okay, we are not. We are actually seeing a wee bit less resolution. If you take a look at the steeple right here, for example, between the two, okay, there's a little bit more detail. Forget about the saturation. There's a little more saturation in how the signal is processed. We take a look at this little church down here. We see more information on the D500. That is resolution. There's not more noise here on the right at all. That lens drops the same light. After that, things are definitely different. Okay. So, it's kind of hard for people to see that because they want to argue that this is a different image than this. No, this is the exact same image as this. Not talking about signal processing and gain and ultimate resolution, because the D500 sensor is different, the signal processing is different, the gain is different. Yeah, those two things are different when we blow up the image. That's not what I'm talking about. I'm talking about what that lens shot out of its little fanny, the rear element. Okay, excuse me. What that lens shot out of its little fanny is exactly the same here as it is here. There is zero difference between here and here. That lens dumped the same light. But additionally so, there is not more noise if you take the exact same DX crop sensor lens and you drop it on a D810, or a full frame camera, as opposed to the DX camera that it is made or designed for. That is simply not true. If you have a math formula that does not include the variables of pixel pitch, gain, and signal processing, then that is what we call an incomplete formula. What really confuses people, and it confuses the hell out of them, is when someone drops a math equation in a video and it's like, oh, there's math, that must mean it's right. No. No. Just because someone has a math equation does not mean they are right. If that equation does not take into account several different variables, then the math is wrong. Thank you for watching. Have a nice day. Bye.